Welcome to the third and final quiz preparation video. This one is over lesson 3-4. We're going to do some more practice problems factoring polynomials, and we're going to look more in depth at the two cube patterns. So let's start just with 4 factoring problems. Anytime that it asks you to factor the expression, the first thing that you should look for is if there is anything in common with every term in the polynomial. For instance, here on number 7, looking for something that every one of these terms has in common. Well, this term has 6 x's, this one has 5, this one has 4. So you can pull 4 out of every one of these terms, and we will start with that. We're going to pull x to the 4th out of each term. Remember, when you factor something out of every term, it's like you are dividing each term by what you're factoring out. So x to the 6th divided by x to the 4th is x squared. Negative 10x to the 5th divided by x to the 4th is negative 10x. And 25x to the 4th divided by x to the 4th is a positive 25. So this leaves us with x to the 4th times the polynomial x squared minus 10x plus 25, which you can factor into 2 binomials. So I'm going to keep my x to the 4th out front just so I don't lose it. And I'm going to factor this trinomial into 2 binomials. If my trinomial starts with x squared, then the first term in each one of my binomials is obviously going to be x, because x times x is x squared. The last terms here must multiply to give you 25, but add to give you negative 10. So hopefully you thought of negative 5 times negative 5 being 25, and negative 5 plus negative 5 being negative 10. So here I have the exact same binomial multiplied by itself, so I can rewrite this as x to the 4th times x minus 5 quantity squared. And that would be my final answer for number 7. Looking at number 8, I look for anything that I can factor out of everything here, and I can factor out a greatest common factor of 2. So I'm going to start by factoring 2 out of every piece, or dividing each term by 2. And I'm left with 3x cubed plus 6x squared plus 2x plus 4. At that point, I'm looking at a polynomial with 4 terms, so I'm going to take the first 2 terms together and the last 2 terms together. So I'm going to rewrite my polynomial as 3x cubed plus 6x squared together, and I'm going to add that to 2x plus 4 together. And I can keep this in brackets together just for right now to keep it separate from this 2. But I'm going to keep writing the 2 so that I don't forget it's there. Okay? So then I'm going to look at 3x cubed plus 6x squared and see what I can factor out of it. What is the greatest common factor of 3x cubed and 6x squared? Well, the greatest coefficient factor that goes into each is 3. And I can pull 2 x's out of each, or x squared. So I'm pulling x squared out of each one of these terms. So 3x cubed divided by 3x squared leaves me with just x. And 6x squared divided by 3x squared leaves me with a positive 2. So I have factored out a 3x squared for my first binomial. Then looking at my second binomial, what is the greatest common factor of 2x and 4? If you guessed 2, you are correct. So when I divide each of these terms by 2, 2x divided by 2 is x, and 4 divided by 2 is 2. So now you should notice that these 2 terms, 3x squared times the quantity x plus 2, and 2 times the quantity x plus 2, they have something in common. They have the factor x plus 2 in common. So I'm going to factor out the x plus 2 from each of these terms. I'm going to keep my 2 out front, and I'm going to pull the x plus 2 out of these 2 terms. and see what I have left. When I factor out the x plus 2, I'm left with 3x squared plus 2, and I can write those as a binomial. Now, since I just have everything multiplied by each other, I can take out the brackets, and I'm simply left with 2 times the binomial x plus 2 times the binomial 3x squared plus 2. And there's my final answer for number 8. Feel free to go back and cover up your work and try it again. Maybe right before the quiz, maybe later tonight, to make sure that you get it and can work towards this answer. So let's look at 2 more. Let's look at number 9 and number 10. Number 9, here I'm working with just a binomial. So here I'm looking at my terms here and seeing what can I factor out of 250x to the 4th and 54x. Well, hopefully you recognize that these are both even numbers, so we know that 2 goes into both of them. So I'm going to factor a 2 out. And I have 4x's here and 1 here, so I can definitely pull 1x out of both of them. So I'm going to factor out a 2x. 250x to the 4th divided by 2x gives me 125x cubed. And 54x divided by 2x gives me 27. At this point, I'm hoping that you recognize that this is the sum of 2 cubes. 125x to the 5th is 5x quantity cubed, and 27 is 3 cubed. So I'm going to look at my rules for the sum of 2 cubes. I'm going to keep my 2x here. Oops. Okay. There is a pattern, a distinct pattern that you use with the sum of 2 cubes or the difference of 2 cubes that we'll look at on the next sheet in just a minute. Since I know that 125x cubed is 5x quantity cubed, and I know that 27 is 3 quantity cubed, then I can use my sum of 2 cubes pattern to factor this. I'm going to keep my 2x out here, and it will be written with the final answer, but it doesn't come into play when I'm working out my sum of 2 cubes. So, my pattern for the sum of 2 cubes starts with just pulling down the first thing that's cubed, which is 5x, plus, and pulling down the last thing that is cubed, which is 3. Then the middle pattern squares the first thing that is cubed, so 5x quantity squared. And then there's a subtraction sign, and then you're going to multiply 5x and 3 together. Then you'll have an addition sign, and you will square the last piece that is cubed. We'll look at this a couple more times. I know it sounds confusing, but the pattern is the same every time. So 5x quantity squared, 5 squared, and x squared is 25x squared. And here I have minus 5x times 3, or minus 15x. And here I have plus 3 squared, or plus 9. And this is my final answer. You, of course, would write it without this errant backwards parentheses scratched out. But 2x times the quantity 5x plus 3 times the quantity 25x squared minus 15x plus 9 is your final answer for number 9. Isn't this fun? Let's try another. Let's try number 10. Number 10, there is something that you can also factor out of both of those terms. Just as a side note, anytime that you have something that starts with a negative, it might be easier to look at and to work with if you'll factor out a negative something. So that something here is the greatest common factor of 3 and 24, or a negative 3. So I'm going to factor a negative 3 out of these two coefficients, and how many x's can I pull out of each? I've got 5 here and 2 here. So I can pull 2 x's out. And I'm going to factor negative 3x squared out of each of those terms. So negative 3x to the 5th divided by negative 3x squared leaves me x cubed. And 24x squared divided by negative 3x squared is negative 8. hopefully this raises a red flag for you, that this is a difference of cubes. Here we have x quantity cubed minus, and here we have 2 quantity cubed. So let's look at the rule for that. Again, I'm going to bring down my negative 3x squared, which will be part of my answer, but doesn't come into play when I'm factoring my difference of 2 cubes. So my difference of 2 cubes. Again, I start by just bringing down the first thing that is cubed, putting a minus sign, and bring down the second thing that is cubed. Then the pattern is much the same as it was in your sum of 2 cubes, except both of these terms will be positive. So I have my first term squared plus my first and last pieces multiplied together plus my last term squared. So I end up with x squared plus 2x plus 4 as my trinomial, and that is my final answer for number 10. Okay, it's time now for me to give you a credit opportunity. You will need to watch all of the rest of this video in order to work a little bit more on the rules of 2 cubes, but go ahead and comment when you're finished watching. On Canvas or YouTube, wherever you watch this, with your name, watched all 3 of these awesome review videos, exclamation point. And that will give you 5 more extra credit points on the quiz. Okay, so let's go ahead and work a few more of these problems. We are now on the 3-4 reteach page. Most teams work through these in class, but I'm going to touch back on them again. This shows you the rules. The sum of 2 cubes. You find what is cubed, and then you'll pull down each part for the sum of 2 cubes. Then you'll square the first, then multiply them together, and square the second. The signs are the same. Here you have negative and positive every time. The rule for the difference of 2 cubes, you'll find out what pieces are cubed. First you pull them down with a minus between them. Then you follow the same pattern, but these are both pluses in your trinomial. Square the first, multiply the first and the second, and square the second. So let's practice that. Okay, they have started by, number 5, by laying out what is being cubed. Here you have 3x being cubed plus 2 being cubed. So since this is a sum, we're going to follow the pattern with a plus in the binomial, and then a minus, then a plus in the trinomial. That's the same pattern for every time you have a sum of 2 cubes. So you could go ahead and sketch that out, and then just fill in your missing pieces. 5 and 7 are both sums. So for what's missing, bring down the 2 things that are being cubed. Then here, you're going to square the first thing that's being cubed, so you have 3x quantity squared. 3 squared is 9, x squared is x squared. Then you're multiplying your 2 pieces. 2 times 3x, or 6x, and then you're squaring your last term. 2 squared, which is 4. So that's your final answer for number 5. Same pattern on number 7. Here I have y cubed plus 3, which is cubed. So I'm just pulling down my pieces, y and 3. Then I'm going to square my first, multiply them together for the middle, and square my last. And that's my final answer for number 7. If you're missing these, you're probably making it harder than it is. So just use the pattern every time and it'll eventually stick. For number 6 and 8, we're dealing with the difference of 2 cubes, so notice the signs in the pattern. The binomial has a subtraction in the middle. The trinomial are both positive. So you can go ahead and shell those out. Then just fill in your missing pieces. Okay, so now let's think about what is being cubed. They've already filled in here that y is being cubed here and 6 is being cubed. Pull down both pieces. Here you'll square the first. Here you'll multiply them together, 6 times y. And here you'll square the second, 6 squared, which is 36. And that's it. For 8, you have x, which is cubed, minus 1, which is simply 1 that is cubed. Pull down your pieces. Square the first. Multiply the two together. 1 times x is just x. And square the last. 1 squared is just 1. Pause if you need to. We're going to look at one more practice problem, and then a couple of tips. Okay, this is number 9 on the additional practice 3-4 sheet. So pause it and find that worksheet. We're looking at number 9, which we didn't get to in any class, so everybody should have this blank on their paper. Here we have a difference of 2 cubes. Noticing what's being cubed here. 64 is what cubed? Hopefully you know that 64 is 4 cubed, and x cubed is x cubed. Minus 1, which is simply 1 cubed. Then we're just going to follow our pattern for the difference of 2 cubes. We start with a binomial with a subtraction in it. Then we have a trinomial where both of the signs are positive. Pull down your 2 pieces, 4x and 1. Here you're going to square the 4x. 4x quantity squared. 4 squared is 16. X squared is x squared. Here you're going to multiply the 2 pieces. 4x times 1. And here you're going to square the last term. 1 squared is 1. So this is your final answer for number 9. One last thing for me to offer you is some notes on other problems that will be on the quiz. Hopefully you're watching this all the way through or you're missing these. Look over 3-1 notes on degrees of monomials and polynomials, the names of the polynomials that we talked about in class, and the leading coefficient when your polynomial is in standard form. So look over the problems that we did in class for those. Your last extra credit opportunity is mid-video. If you are forwarding to the end of this video just for the extra credit, you're going to have to watch the whole thing because the extra credit opportunity is mid-video. Thanks for watching.